Let's define what are analytic functions. So let S be a set of complex numbers, which is the domain, and R be another set of complex numbers, which is the range. Then if f is a function defined from S to R such that to every z in S there is a complex number w in R such that f of z is equal to w, that is value of f at the point z is w. If there exists a number w in R such that f of z is equal to w, then we can call this w is a complex variable. So since these both are complex set of complex numbers, here obviously w will be another complex number u plus iv, where again this u and v consists of x and y. Okay, then that is a complex variable. Now coming to analytic functions. Analytic functions are functions which are differentiable and continuous. Okay. Now what are differentiable functions? Functions which have derivative. They are differentiable functions. Means if you can find the derivative of the given function, this is the simplest way of explaining. So if you can find the derivative of a given function, then such functions are differentiable functions. And coming to continuous concept, if a function f of z is given, this f of z is said to be continuous at a point z equal to z0 if limit z tends to z0, f of z is equal to f of z0. Then you can say that function is continuous. That means in simple sentence if we say if the value of f of z0 exists, then you can say z is continuous or f of z is continuous at the point z is equal to z0. Then so if w equal to f of z is analytic in a domain D, and if and only if the first partial derivatives of u and v satisfy the Cauchy-Riemann equations and partial derivatives are continuous too, then that function is analytic. That means if for a function to be analytic, the two conditions are first partial derivatives of u and v. That means dou u by dou x, dou v by dou x and all. First partial derivatives of u and v are there, and if it satisfies the Cauchy-Riemann equations, then only that function is said to be continuous.